Good morning, junior physicists. Today we go back into our motion graphs and back to some of the thoughts that had come up in one of the Seneca classroom assignments about slopes and areas. So some key points, if you don't have these written down somewhere, you better get to know them. The slope of a displacement time graph is velocity. The slope of velocity time graph is acceleration. The area under a velocity time graph is displacement, and I'll explain that more in a little bit. The area under an acceleration versus time graph is change in velocity. This is the heart of kinematics. This is where so much of the even calculus came from, with people trying to wrap their heads around these ideas. Okay, so we're going to focus on the velocity time graphs. So we're going to be talking about slope, meaning acceleration, and area, meaning displacement. Alright, so here is a motion graph. It's broken down into 4-second intervals, although the last one's a little long, but we're going to stop at 28 seconds, so we're going to stop out here no matter what. Okay. And so we see, different things go on in different columns and different columns. Well, yeah, I'm tired. I'm not going to lie about it. We see different things going on in different regions of the graph, and we're going to get into discussion of what they all mean as we go through this. So the first thing we're asked to just take note of is, in any given interval, is the velocity positive, negative, or zero? So that's really just looking at the graph and saying, is it above the y-axis, is it below the x-axis, is it on the x-axis? And I know somebody's going to say, well, this point crosses over, right? But we're talking about the interval, so we're talking about what's going on in here, and that is all above the x-axis. So the first time interval is definitely positive, okay? Whereas the second, third, and fourth are all below the x-axis, so they're all negative velocities. The fifth one is right on the x-axis the whole time, so that's our zero. And then we go above the x-axis for the last two pieces, so we're going to go positive and positive. Okay, so really that's pretty simple, and I'll explain how that ties in. It's very much related to the previous assignment on creating and analyzing graphs, where we talked about how positive velocities match, or the sign of the velocity matches up with the acceleration to determine the shape of a displacement graph. So we're going to put a lot of pieces together here. In any event, okay, so B, in the third column, calculate the slopes of the lines to determine the accelerations. Alright, so slope is change in y over change in x, right? So let's just talk about this first interval here. I'm going to switch over to my draw function if I can move this enough to grab it. Okay, my little window's in the way. All right, so the rise, so it's rise over run, but remember it's really change in y over change in x. So we're going from 4 down to 0, so that's negative 4, and the units technically are meters per second on the y-axis, right? And then over the change in x, well, the change in x is our time, and that's 4 seconds. So that's a nice, easy piece of math to figure out. We'll just leave it like that for the moment. Right? So I'm not going to put in the acceleration yet because I have to keep switching in and out of the draw. So I'm just going to keep calculating my slopes. So the next segment goes from 4 seconds to 8 seconds, and we're going from 0 down to negative 4. So again, I'm going exact same thing. I'm doing negative 4 meters per second in 4 seconds. So this is negative 1, this is negative 1. Well, look at this line. They have the same slope. It's all really one line. We just treated it as two parts because part of it's in the positive region, part of it's in the negative, but it still has just one acceleration. Alright, so now I shouldn't have to even explain this, but I will, okay? This is a horizontal line. Slope is 0, okay? And the reason for that is the change in y over change in x. So change in y, I go from negative 4 to negative 4. Well, negative 4 minus negative 4 is 0. So we would have 0 over 4 seconds, 0 meters per second over 4 seconds. So again, we get 0. Now this slope is going from -4 up to 0. So this is a positive slope. So we're going up by 4 meters per second in 4 seconds. Here we have another horizontal line. Okay, so I'm just going to put the 0 right on that one because that's a 0. All right. This line is just very much like this line. Okay, we went from -4 up to 0. Now we're going from 0 up to +4. So again, it is a positive change in y, and the time is always going to be +4. Okay, now I know we could go out to 30, but we're going to stop right out here. I gotta move myself out of the way here. That's a weird thing to say. Okay, we're just going to stop right here. So we're going to say that we're going 0 again over 4. I guess I should have, if I do it here, I should have done it here as well. 0 over 4. All right. So now I could go in and say that my accelerations were -1, -1, 0, 1, 0, 1, 0. All right, so I'm just going to plop them in here real quick. -1, -1, 0. Do you have to put the positive sign? No. Okay. I'm putting it just to emphasize the point because we're going to talk about whether velocities are positive and accelerations are negative later. Okay, but that's all that we're doing there. All right, if you need to look at that again, pause the video. I'm going to delete these so I can now go in and talk about my next stage, calculating areas. All right, so actually, before I switch back to my draw function, let's just write area of triangle equals 1/2. Go back. I didn't want that. Area equals 1/2 times base times height. And for a rectangle, it's just base times height or length times width, whichever way you want to do it. I'm just going to keep it as base times height. All right. So literally, when we talk about areas, okay, we're doing that, just that, okay? But it's always the area between the x-axis and the line, okay? So the first area I'm going to work with is this triangle right here. That is what we're talking about. Obviously a triangle, so we're doing 1/2 base times height. So I have 1/2 times the base, well that would be 4 seconds, times the height, I guess I should put a little times there, a little times there, times the height. The height is going from 0 up to 4 meters per second. Now again, I'm going to put in the units here to emphasize where we're going with this. So we have 1/2 times 4 times 4. Okay, so 1/2 of 4 is 2, times 4 is 8. So the area here is 8. And in terms of units, seconds times meters per second, well, the seconds are going to cancel out. We're going to be left with meters. Well, that makes sense because we were said that the area would be a displacement. So we know that in this time interval, this object has moved 8 meters from wherever it started. Okay. All right, so now we're going to go to the next interval, and we're going to go another 4 seconds. We're going to go and talk about from here to, oh, I can draw. Ooh, good skills. All right, so this triangle, well, despite the fact that my drawing is terrible, this triangle and this triangle are going to be the same thing. This is 4 meters per second. This is 4 seconds. So we're going to get exactly the same area, except my height is actually a negative now. So it's really 1/2 times 4 seconds times negative 4 meters per second. Because we're below the x-axis, we have to do it with positive negatives. Remember that displacement is a vector, so it does matter. So instead of positive 8, this displacement is negative 8. So right away, we could kind of infer that, this person or thing moved 8 meters in one direction and then 8 meters in the other direction. So right here, I know they're right where they started. They haven't gotten anywhere yet. All right, so the next 4 seconds brings us out to 12. So now we have a rectangle. So we're going to do the base, 4 seconds, times the height, -4, because we're going down. So that means, I guess I should write that up here. We're doing 4 seconds times -4 meters per second. I'm not going to keep writing the units, that's for sure, not in draw, because I have draw challenged as it is. All right, so that means that this area is -16 meters. All right, so now this triangle is a mirror image of this one. It's below the axis. They're both, this is the same as this. This is the same as this. We have congruent triangles. Ooh, sorry to scare you like that. All right, so we have -8 meters here. I don't really need to do too much there. In this segment, there is no area. It's right on the x-axis, so the displacement is 0 meters here. In the next segment, we go out to 24 seconds. Okay, so I have this triangle, which is just like this triangle. So the area is 8 meters. And finally, let me get out of the way, we're in this rectangle over here, okay, which is like this one, except it's above the x-axis. So instead of being -16, it is positive 16 meters. All right, so that means now I should be able to get out of draw, come in here and say we had 8, and then -8, then -16, and then -8, then 0, then +8, and then +16. So there are our displacements. All right, you can pause the video if you need to. I'm going to get rid of some of this extra noise here. Maybe I'll leave some of those lines out. All right. Sure, we'll get rid of that. All right, the rest of the lines, I guess, are relatively innocuous. All right. So the next thing we're asked to do is to sketch a graph of the acceleration versus time for each time interval. Okay, so I marked off the time intervals 4, 8, 12, 16, 20, 24, 28. Okay. I guess I can label a couple of them. I'm not going to, again, I'm not very good in draw, so I really don't feel like drawing out all of them. It's just weird. Why are you moving? 4, 8, 12, etc. Okay. So all that we're doing is recognizing that the acceleration is staying the same for the first 4 seconds at -1, right? This slope is constant here and into here. So for actually the first 8 seconds, the slope is -1. All right, so I'm going to mark my graph, and just to spread it out a little bit, I'm going to say, let's see, so 1, 2, 3, 4. I'm going to put +1 here, and 1, 2, 3, 4. I'm going to put -1 here, just so that's not what I did. Hello. Ow, this is bizarre. 1, 2, 3, 4. Okay, stop moving on me. All right, anyway, you get the idea. I don't know why it keeps moving. All right, so we know 1, 2, 3, 4. All right, it is there. For the first 8 seconds, we said that the acceleration is -1. So we just drawing that. That's it. Now, I don't know why the line moved. Bear with me. Again, I'm draw challenged. Okay. Then the next 4 seconds, I believe it was 0. Okay. Yeah. So we go -1, -1, 0, 1, 0, 1, 0. All right. So we're going in 4-second intervals. So we're at 0. Then we're at 1. And we're at 0, and again it's moving on me, don't know why. 1, and then 0. Alright, anyway, that's the basic idea. If you want to connect the points and talk about what's going on here at the boundaries, that's okay. The question was about the intervals, so I'm focusing on what's going on in between. So it's constant acceleration here, constant acceleration here, constant here, constant here, constant here, constant here. And in between, yeah, there's changes in acceleration, but we in this course are not going to talk about a change in acceleration. So don't sweat that. All right, so that's question 2 done. So this is my acceleration, A versus time, T graph. All right, so let's now go down and talk about the next question, which is about displacement again. Complete the table by adding up the displacements of each time interval to determine the total displacement at each time specified. All right, so I'm going to pause the video for a second. I'm going to copy some of the stuff on question 1 down here so I don't have to keep scrolling constantly because it's going to get to be a pain in the butt. All right, so I have the graph from the first question and the table that we filled out. Okay, so now we want to first find the total displacement. Okay, total means sum. We're just adding up. We're assuming it started at 0. Okay, so we'll just put that big fat 0 there to start. Then we know in the first 4 seconds it went 8 meters. So 0 plus 8 is 8. In the next 4, we know it went -8. Well, 8 and -8 is 0. In the next segment, it went -16, 0, and -16 is -16. In the next segment, we went -8. Well, -8 and -16 is -24. Next segment, we went 0, so we stayed at -24. Next segment, we went +8, so now I'm going back up to -16. And then the last segment, we went 16, so we're going back to 0. So basically, this is one big trip back home with a little bathroom break in between, maybe, or whatever. I don't know. But in any event, that's what the displacement is. All right, so now we're asked to make a displacement versus time graph. And this is where we got to refer back to yesterday's or the previous worksheet on, again, creating and analyzing graphs. You have to know the different shapes, and knowing whether the velocity is positive or negative or 0 and the acceleration is positive, negative, or 0 defines the shape of the curve. So we know from 0 to 4, we're going, from 0 to 4 seconds, we're going from 0 to 8 meters. But is it a straight line or is it a curve? Well, we look and we see that there is an acceleration, and it's a negative acceleration. So it definitely has to be a curve, okay? And we know that we started with positive velocities, okay? So that means, okay, if you remember the shapes that we talked about, that the curve should look something like this, where it's going up like that. So in the first interval, I probably should have done 4 lines or whatever, but I'll call that my 8. All right, so now I'm going to have work with some weird numbers because I did 3 lines for 8, but, you know, so be it. Okay. Now, in the next interval, we're going from 8 back down to 0, okay? And again, we have a negative acceleration, but now we have negative velocities, okay? So that means when you have negative, negative, we're going to get kind of the mirror image to that. We're going to get a curve that goes exactly the opposite curves back down like that. So this should be like one big curve. Almost looks like one big curve there. All right, so we're back at 0. All right, so I guess I should label a few points here real quick. So we're going to have to get down to I think -16 next. So if 3 lines is 8, then 1, 2, 3, 4, 5, 6. That should be -16. I hate you, draw. And 1, 2, 3. This will be -24. We're going to need that. All right, I guess it's good that I screwed up because my spacing would have been an issue. All right, so now that I've labeled, let's go back. All right, so now we're going from 0 to -16. I look at the graph, okay, so in this next segment, okay, we have 0 acceleration. When there's no acceleration, that means it is a straight line. Now, straight, I don't necessarily mean one way, where's my camera? One way, or another, or even another. I'm just saying it's not curved, okay? So it is a straight line when there is no acceleration, okay? Now, we have to then look at our velocities, okay? We know there's no acceleration, but it's a negative velocity. That means we have to have a negative slope, okay? So a negative slope means downward. So we're just sloping down, or my pointer, from here, wherever -16 is here. So we should have one relatively straight line there. And for me, that's pretty good. You gotta admit, that is pretty straight. Yeah. All right. Anyway, let's go back and look. All right. So now we're going from -16 to -24, and we have a let's see, a positive acceleration and a negative velocity. Okay. So this one, again, got to really refer back to that sheet from yesterday. We're going to have something that looks like this, like a curving. All right, maybe went a little too far, but yeah, you get the idea. Okay, so this curve, okay, is giving us a positive acceleration on a negative velocity. Okay, notice that it's not getting as steep; it's getting shallower. That's how I know that the accelerations are opposite to the motion. Okay, when a curve gets deeper, then they're in the same direction. All right, so what happens next? We go from -24 to -24, so that means we're not moving at all. So I know in the next segment, I'm just staying exactly at -24, so that's a horizontal line. And again, let me put this here first, even though I'm sure Draw's going to move it. Okay, we had a 0 acceleration and a 0 velocity, so that's saying, yeah, there's nothing happening, there's no motion. All right, in the next segment, we're going from -24 up to -16. We have a positive acceleration and a positive velocity. Okay, positive velocity means the slope has to be going up, but it's accelerating. That means it's a curve going up. Okay, so that means that it's got to be increasing in slope in the upwards direction, and so we're going to have something, and we're going to end up at -16. Let me put a mark there so I know where I am. All right, so that means we're going to have a curve that looks something like this. And then finally, in the last segment, we're going from -16 to 0 with no acceleration and a positive velocity. No acceleration means no curve, okay? But a positive velocity means that we have to have a positive slope. And I know my image just made that look backwards, sorry. I don't know how you see it actually. Maybe it didn't make it look to me it did. So positive slope, we just have to make it one line going up and to the right. That is our displacement time graph. All right, so that pretty much concludes today's little thing. Okay, there is homework. You're not doing any graphing actually for the homework. Oh, part of my graph got bumped down. Okay, oops, whatever. So what you're doing is just the slopes and area stuff. So you're taking this graph, okay, broken down into 4 segments, not all equal time, by the way, 10, 20, 30, and then we go out to 50, so be careful. And you're doing more or less like we did on the first table there. Didn't want to do that, but whatever. Okay. So you're just going to figure out whether the velocities are positive, negative, zero, figure out if the acceleration, calculate your slopes for acceleration, calculate your areas for displacement, and find the total displacement, which was basically what we did in this table, right? This represents our total displacement. All right, get that done, upload it to Canvas. See ya.